Now here we have the Kingston A1000 SSD. This is an NVMe drive, or PCI Express. However, unlike most SSDs, as we'll see for this Samsung one here, which use NVMe, we can see this one is M and B keyed as opposed to just B keyed. This will allow it to fit into SATA slots, even though it won't necessarily work in them if a drive does not support NVMe. A system does not support NVMe, which gave me some confusion with this machine that I'm currently upgrading in the first place. The reason it appears to be keyed like this is, unlike most drives, it only uses 2 PCI Express lanes. Many have the capability to use 4 PCI Express lanes, which is what at least some of those extra pins are for. This means that write speeds are limited to about 1000 megabytes a second, and read speeds are 1500 megabytes a second, whereas with 4 times devices, you'll typically find these around the sort of 2.2 to 2.7 region. And I would assume the theoretical limit is actually 3 gigabytes a second. So you are getting slightly lower performance on this, but it's still 3 times what you'd expect for a SATA drive, with very little cost difference. So we are going to get this fitted into our machine, and we will be running some comparisons to the Samsung drive that was fitted previously. Now, looking at the performance of these SSDs, and what we're doing first is comparing side-by-side in Crystal Disk Info. So this gives us some relative performance in sequential and random read tests. And what we see here is there is a big advantage with the stock SSD. In terms of these peak transfer rates you get from the Samsung drive, it's shipped with almost 3 gigabytes a second, whereas the Kingston drive does reduce this substantially to sort of 1.3 gigabytes a second, and it takes an even more significant hit on read performance because it is using a less performant type of flash memory, I believe. When you're looking at random reads though, which is what really affects your sort of loading times and things like that, there's less of a hit. So when you've got lots of different tasks happening, which for a laptop for sort of general usage may be the case, you're taking less performance hit, and still a large SSD which does not have huge sort of theoretical performance there is still going to be much more pleasant to use than a mechanical hard drive. What we're going to do next is just look at how this sort of affects the system boot time, and I'm going to apologise just now for the quality of the filming. This laptop for some reason doesn't have a easily usable HDMI output. So just taking the example of boot time, we can see here, although there is a slight performance advantage with the Samsung SSD, really it bears out about 1 second difference in boot time, which really means it's a small difference in reality, even though the theoretical numbers seem high. I hope you found this video useful. Obviously I understand this is just a very quick test, but it does show that while you will lose a little bit of theoretical performance, the actual real-world impact of it isn't huge, and compared to the price for a similarly performant NVMe SSD, I think the A1000 actually represents pretty good value. Let me know what you think in the comments though, I'd love to hear your thoughts, and be sure to like and subscribe if you'd like to see more from us in the future. Thanks for watching.